Tes 1, 2, 3. Boleh dengar suara saya? Cuba komen tepi. So sekarang ni kita ada 23 untuk student. Sepatutnya untuk yang 3 kelas kita ada lebih kurang berapa? Dalam mungkin 100. So kamu semua ni berada di mana sekarang ni? Di library, di asrama ataupun di cafe? Okay, saya akan cuba share screen ya. Nanti kamu respon, nampak tak saya punya screen nanti? Okay, boleh nampak saya punya screen? Okay, suara saya jelas ya, lepas saya cakap ni. Okay ya, so saya nak sekarang ni kita ada around 42 42 student. So kalau kamu nak jimat tak semestinya seorang satu untuk tengok live streaming YouTube ni, jadi boleh kongsi dengan kawan-kawan yang lain. Okay, untuk yang lecture, so first chapter untuk SF015 chapter 1 is physical quantity and measurement. Kalau macam kamu ada masalah, kamu boleh tulis dekat ruangan komen tu ya. So nota kamu sudah ada ke? Lecture note untuk yang chapter 1 ini. Lecture note ada yang sudah ada kah? Kalau yang sudah ada tu mungkin boleh kongsi. Because ada beberapa orang pelajar saya sudah bagi lecture note. Mungkin kalau yang ada tu boleh kongsi dia punya link tu. Tapi tidak apa, kalaupun tiada, because yang first class ini kita just go through saja. Nanti lepas ni dekat group tu saya akan bagi untuk lecture note yang saya pakai sekarang ni ya. Okay. Okay. So tidak apa, yang tiada tu tak. Okay, nanti saya akan bagi sekejap lagi untuk chapter 1 ya. Okay, physical quantity and measurement. Okay, untuk yang chapter 1 ini, kita akan cover physical quantity and measurement. So first is of dimension physical quantity. Okay, yang ini. Right, and the next is scalar and vector quantity. And the next is vector multiplication. And the next we have a vector resolving vector and scalar and vector product. So this is the punya overview for the first chapter. And for the first subtopic 1.1, this is a learning outcome. So learning outcome for dimension of physical quantity. So the end of this chapter, students should be able to define dimension, mean the dimension and derive quantity, right? And homogeneity of equation using the dimension analysis. Okay, semua ni kita akan cover untuk chapter yang pertama ni. Okay, so the next kita akan pergi kepada. Okay, first is this is a concept basic quantity, symbol and unit, right? Okay, saya akan pakai pen ya untuk memudahkan kelas ini. Sekejap ya. Okay. So look at the basic quantity here. The basic quantity, first you have a mass. So mass, the symbol mass is M, small m, mass, and the unit is a kilogram, right? So first is a mass, this is basic quantity. And second is a length, right? This is length, symbol is L, and the unit is a meter. Unit, if you measure the distance, let's say the distance from A to B, so the distance, let's say this is 1 meter, this is 1 m. And for the mass here, say you measure the mass 30 kilogram. So the 30 is a magnitude and the kilogram is a unit for the mass. Right? So kalau siapa-siapa yang ada tidak dengar suara ataupun tidak jelas sila komen dekat tepi tu. Saya boleh baca dan boleh baiki kalau ada macam ada masalah. So far okay kan? Boleh bagi respon? Okay. Okay, so Daniel cakap okay, Tin cakap okay. Okay, so continue. So next is we go to the next, the third basic quantity is time. Time, So how to measure the time? The symbol time is T, and the unit is a S, small s. This is a second. Let's say the time taken from A to B, okay, maybe nak kata suara tidak jelas. Okay, yang lain tak pasti Saya rasa okay. Kalau boleh guna earphone tu dia nampak jelas lagi Right. Okay, so let's say the time taken from A to B, this is 1 second, right? So this is how you can measure the time T with the unit seconds. Okay, so the next is electric current, I. So how to measure the electric current? The first is a unit is ampere, A, right? So maybe in the lab or physics experiment, the electric current or unit electric current ampere can use to measure the magnitude of the current flow in the circuit. Like say is 3 ampere, right? So this is how you can measure the current flow in the circuit. So the next basic quantity is temperature T, right? The symbol is theta. Our unit is Kelvin. And the next is this is on the chemistry, and you can use amount of substance. The symbol is N. And how many mole? How many mole? So this is a basic quantity. Right? You have a mass, length, time, electric current, temperature, and mole substance. Mole. So go to the next. Okay. Okay. And next is a dimension can be treated an accurate quantity through the procedure called dimension analysis. Okay, so this dimension analysis, dimensional analysis. So to use the dimension to analyze first, okay, yang ni kita akan tengok nanti bagaimana kita boleh gunakan kaedah dimensional analysis ni. So first is to find the unit of the physical quantity. Okay, to find whether the physical quantity is dimensionally correct or not using by the principle of homogeneity. So first is okay. Okay. So this is a sample. Okay, say you have the basic quantity, you have a length, right? Length. Okay, sorry. Mass, okay, right? Mass M. As you know, the mass unit is a kilogram. Okay, like say you have a mass of the object is 30 kilogram, right? So now, second you have a distance or length, say 30 meter. This is distance. So this is the unit meter, and this is magnitude. And you have time t unit. Say you have 30 second. So you have a mass, length, time, right? So first, okay, velocity. So velocity, the symbol of velocity is v, right? V. So the formula to calculate or find the velocity is a displacement divided by time t. Ini adalah persamaan yang mana kamu boleh gunakan untuk mengira velocity, right? So velocity here, velocity is a distance or displacement s divided by time t. S is a displacement or distance. This is if you refer to the basic quantity is the length, and the time t, time. This is basic quantity. So you have a basic quantity. So as discussed earlier, we have a length, we have a mass, we have the time t. Okay, we have a temperature, we have a amount of mole, we have how many lengths, mass, time, temperature, mole. So velocity here, velocity is combination two item from the basic quantity length and time t, right? So v is equal to velocity is equal to length divided by time t. So you have a v velocity. Okay, satu item baru kita panggil sebagai velocity kat sini. Okay, so this is kita panggil sebagai derived. Okay, derived quantity. So meaning velocity is produced by the item, length and time t. This is basic quantity. This is basic quantity. Basic quantity. Right? So velocity is a derived quantity. Ataupun ini adalah kuantiti asas, and velocity is a derived. Derived in Malay is a kuantiti terbitan, is it? So V is a S divided by T, right? So next example, let's say we have a equation for the yes, Aida Nazira said that another is a current. Yes, a basic quantity, current. Yeah, current we have ampere, right? So you can refer to the table. As I said earlier, we have the list of basic quantity. So the most important here is you must know first you have a basic quantity, and the next we have a derived quantity. So how you can find, how you can produce a derived quantity? So derived quantity is come from or produced by the basic quantity. Okay, so far okay. Kelas yang lain. Ini sebagai pengenalan saja untuk hari ini sambil saya nak test talian internet kelas kita sambil introduce untuk first chapter. Actually first chapter ni kamu dah belajar okay, di peringkat SPM. Okay, so ini ulang balik. Macam saya katakan tadi, kalau ada yang nota yang belum dapat tu, after this saya akan bagi link untuk nota yang kita bincang ya. Okay, so okay, continue to okay. This is if you look at the lecture note here, so we have a example. So okay, ada student tanya we have luminosity. Actually yang saya nak bincang kat sini, yang basic quantity yang kita bincang kat sini yang biasa kita pakai adalah mass, length, time, electric current and temperature. Actually we have another two amount of substance yang ni banyak kamu bincang dalam chemistry kimia, ataupun amount of luminosity itu jarang kita guna. That's why saya hanya fokus kepada mass, length, time, electric current and temperature. So yes, kita ada lagi yang amount substance, Okay, kandela untuk yang apa, amount of okay, itu melibatkan light, cahaya. Ya, betul apa yang dinyatakan tadi oleh siapa tadi dia tanya, luminosity tu. Okay, so okay, saya nak terus kepada yang the next. Okay, saya nak bagi contoh yang ini ya. Okay, so this is a example. Uh, okay, let's say you have a velocity. So as I said, velocity is come from the equation s divided by time t. So now you can calculate velocity by using the item s. S here is a displacement. S is a displacement or distance or length is a basic quantity. This is basic quantity, right? And also time t. So combination s and t, displacement and time t produce a new item here. So this is a derived quantity, right? So how you can relate to the dimension? So apa yang kita nak jelaskan mengenai dimension? Okay, first is a symbol of dimension. So symbol of dimension, if you look at the lecture note, dalam lecture note itu dia simbol macam ni, dia macam apa, bracket macam tu kan. Let's say you have a velocity. So now if you put the value or the symbol V here, velocity in the bracket, meaning this is a dimension of velocity. Dimension of velocity. So dimension of velocity, if you look at the basic quantity, so the first is mass, okay, so m. So the basic quantity, sorry, the dimension for the mass is equal to m, capital M ataupun the big M. This is a dimension, the symbol of a dimension of the mass, big M. And the next we have the length, right? So length is L. This is basic quantity. So what is the dimension of the length L? So the symbol of the dimension of the L length is a capital L, right? So this is dimension. So the next is a time T, time. So the time is a basic quantity. The symbol is the small t, right? So now how you can, what is the dimension of the time t? So the dimension of the time t is a t, right? Okay. Okay. Yang lain tu ada. So saya nak fokus kepada tiga ni dulu Senang kamu nampak So we have a basic quantity. We have a current, right? Current, ampere. We have right, amount of substance, mole, right? So I focus on the three item here. We have the mass, length, and the time t. So the first is the symbol of the dimension is here. This is dimension, dimension, and the dimension for the mass is m. Dimension for the length L, and dimension for the time t. So back to the example here. Okay, velocity. So look at the equation here. So now the velocity, dimension of the velocity v, the dimension of the velocity, as you know, the velocity equation is a displacement or length divided by time t. So what is the displacement or length? Dimension for the length yang kita bincang tadi apa? L. Dimension for the t is time. So divided by t. So the dimension of the velocity or you can use the LT. You can put the T here is a LT minus 1. So meaning this is dimension of the velocity. Okay, so I go to the next example here. Let's say you have the acceleration, acceleration A per Newton. Acceleration equation is a V divided by velocity divided by time t. So as you know, velocity is a displacement s or jarak or distance divided by time t. So what is the dimension of the velocity? What is dimension of the velocity? So dimension of velocity is length divided by t. Dimension for the s is a L. Dimension for the t is a t, time t. So this is LT. Kita bawa t ke atas. This is t minus 1. So now the dimension of the acceleration of percutan A is a velocity divided by time t. And dimension for the V here is equal to LT minus 1, power of minus 1, and divided by dimension for the t, dimension for the time t is a t. Or you can ringkaskan dia lagi, or naikkan t ke atas, LT minus 2. So this is dimension. How you can find the dimension of the acceleration A. Okay, class. So this is the basic process that you can use to find the dimension. Okay, so go to the next example, right? Okay, the next example. So let's say we have the equation force. Force. Force is F. So how to calculate force? Equation for the force F is equal to MA. So this is equation for the force. So how you can find the magnitude, a dimension for the force? So the first you must consider this is mass M and this is A. So the first you must find the dimension for the mass. So dimension for the mass, yes, you just refer to the basic quantity. Mass is a dimension, symbol for mass is M, capital M. And you have a acceleration. So ini kita dah bincang tadi kan, acceleration is a dimension is LT minus 2. So now dimension for the force here is equal to M L T minus 2. So this is dimension for the force. Okay, class. So far. Any question for, first is a basic introduction for basic quantity. And the second is how you can use a basic quantity that you can produce the derived quantity. And the next, how you can use a dimension that you can find the dimension, let's say from the basic quantity, we have the velocity, we have the acceleration, we have the force, meaning the number of the basic quantity, we have the fixed basic quantity, 7, or yang biasa kita pakai tu kan macam mass, length, distance, time, right? Ada 5. But derived quantity banyak. So formula dalam fizik banyak kan? That's why derived quantity banyak. Tetapi derived quantity is produced by the basic quantity. From the basic quantity or from the derived quantity, you can find the dimension for the each item in the derived quantity. Right? Okay. So untuk hari ni saya rasa kita tak perlu 1 jam lah. Saya cuma nak test line macam mana. So suara macam mana. Actually saya berada di pejabat sekarang ni. Saya harap kamu dapat So far saya rasa respon tu lancar. That's why, actually apa yang saya bincang ni sebenarnya tak ada masalah. Kalau yang tak berkesempatan, but because ni saya buat live dan dia record kamu boleh balik nanti bagi tahu kawan-kawan yang tak dapat, you can go to the my channel Nazar to you. Apa yang kita bincang ni saya akan letak balik dekat channel Nazar to you. So ini kamu boleh tengok balik dekat channel saya. Yang penting kamu pergi kat channel saya. Actually kat channel saya tu saya sudah mula letak contoh-contoh soalan pasya, contoh-contoh soalan-soalan latihan, soalan tutorial. Saya akan update setiap hari. So that's why you can, kalau boleh setiap hari you can refer to my channel Nazar to you, so you can have latihan, contoh jawapan, pasya question banyak di sana. Right? Okay. So sikit lagi ya. Okay. So this is a dimension. Okay. So if you look at the right. Okay. So look at the lecture note. This is acceleration. So the lecture note here show you that how you can find the dimension of the acceleration. Simple kita dah bincang tadi ya. And this is P. Part P is pressure or power, or this is P is equal to M times V. So dimension for the mass is the capital M or the big M. So dimension for the velocity is LT minus 1. So the P here is equal to MLT minus 1. And this is a unit. Unit for the acceleration, unit for the P, kilogram meter per second. Right? Okay, the next we have yeah. Okay. This is the force, right? Force, how you can find the dimension for the force. Ni pun kita dah bincang tadi. Okay, MLT minus 2. And this is rho, this is a density. Okay, ketumpatan. How you can measure the density? This is a mass divided by V is a volume. So the dimension for the mass is a M. Volume here, or isi padu, we have let's say panjang, darat lebar, darat tinggi. This is a volume, isi padu. So we have a panjang, lebar, tinggi is a L, length. We have a 3L here, L times L times L. That's why we have a ML minus 3. So maksudnya kat sini, kamu pergi mana-mana saja, rumus fizik, fizik equation or formula, kamu boleh guna konsep dimensi ni, or dimension ini untuk membuktikan ataupun untuk mencari dia punya dimensi dia. Dia ada dimensi dia. Yang penting kamu perlu tahu basic dia tadi. You can refer to the basic quantity. So kita ada length, kita ada mass, kita ada time t, kita ada apa tadi ya? Biasa kita pakai ni length, mass, time t. Okay. So ada yang pelajar tanya, what happen kalau kita ada, if you have a number or 30, so what is the dimension for the 30? Okay, ini seumpama dia tidak mempunyai dimensi. Okay, so maksudnya satu lah maksudnya kan, dia no dimension, right? Okay, so okay, saya rasa kita ada sikit masa lagi sebagai pengenalan untuk hari ini. Okay. Ini dia agak panjang sedikit, tapi tidak apa, kita tengok contoh ya. Okay kelas sebelum kita habis, saya nak bincang yang ni sekejap. Okay, so now, so this is equation. Let's say power is equal to K times A times T power of 4 minus T power of 4. So this is the equation. P is a power, or net power, right? And A is a surface area. A is a surface area. and the time t1 and the t naught is a temperature. So now the question asks you to find the dimension for the, let's say, dimension for the p, right? Okay, sorry, this is not the question asks you to, right? Okay. Oh, dia agak panjang sikit. Saya nak pergi kepada yang, okay. Saya ambil satu contoh soalan kat sini ya, supaya senang sikit ya. Okay. Okay, actually we have a concept homogeneity. Okay, so this is a homogeneity equation using the dimension analysis. Okay, homogeneity itu apa? So saya cuba ringkaskan ya. Ini last kali PS perlu kita habis. So, sorry. Okay. Saya ambil satu contoh ya. So this is a homogeneity. So, macam mana kita nak selesaikan soalan ini? Homogeneity of equation using dimension analysis. Okay, sebenarnya dia punya konsep dia senang saja. Okay, let's say kita ada apa? Equation. Saya ambil equation V is equal to U plus AT. Actually, this is a equation, linear motion equation. This is chapter 2. Tapi tidak apa, kamu terima saja. Okay, persamaan ini. Tapi persamaan ini, kita boleh buktikan dia. Using by homogeneous equation using dimensional analysis, kita boleh buktikan rumus ini betul ataupun salah. Macam mana cara dia? So you can use a concept dimensi dia. So V here is a velocity. So velocity, as you know, dimension is LT minus 1. So this is dimension for the velocity. Kan kita dah bincang tadi, velocity is a distance divided by time t. So dimension of the velocity, because S over T, S is a L, T is time, T. That's why the dimension for the velocity is LT power of minus 1. So, kita nak buktikan bahawa rumus ini betul. Ini kita panggil sebagai bahagian V ni dipanggil sebagai left side ataupun left hand side bahagian kiri, yang U plus AT is a right side. Right? Di sebelah kanan, di sebelah kiri. Rumus ini betul. Equation correct if dimension ataupun dia punya dimensi untuk di sebelah kiri sama dengan di sebelah kanan. Okay? So kita perlu buktikan. But if you look at the equation here, let's say the velocity dimension is a LT minus 1. So kita kena pastikan di sebelah sini, di sebelah kanan ni mesti dimensi dia adalah sama. So bagaimana kita nak buktikan dia? Right? So U is a velocity. This is a V is a final velocity. This is a final velocity. U is a initial velocity. Halaju akhir, halaju awal. Meaning the unit for the velocity, final velocity and initial velocity is the same, ataupun dia punya unit dia adalah sama dalam velocity is unit meter per second, or dimension is the same, LT minus 1. This is dimension for the U. So plus A is acceleration. So as I said, acceleration dimension is LT minus 2. And the time t dimension is the t. So now this is LT minus 1, LT minus 2 and time T. If you look at the equation here, this is we have a LT minus 1 and this is LT minus 2 times T. This is a LT minus 1. Okay? And the left side, we have LT minus 1. So if you look at the equation here, if you compare right left side and the right side here, so we have a same dimension. So meaning ataupun ini membuktikan bahawa rumus ini adalah betul. Equation, this is a correct equation. This is the process how you can use homogeneity of equation using the dimension analysis that you can prove that the equation atau persamaan itu betul ataupun salah. So, jadi saya rasa untuk apa-apa latihan ataupun perbincangan lebih detail nanti, kamu akan pergi kepada tutorial, kamu akan bincang dengan lebih detail dengan pensyarah kamu nantilah. Okay, tapi untuk minggu ni dan minggu depan mungkin tutorial pun dalam bentuk lecture nanti lebih, tapi dia akan bincang dengan lebih detail contoh soalan dan sebagainya. Tetapi jangan lupalah contoh-contoh soalan ataupun penyelesaian soalan you can refer pada saya punya channel Nazatul YouTube, banyak saya bagi contoh-contoh soalan pasir peperiksaan lepas pun ada. Kamu boleh study kat sana. So any question atau masalah you can refer dekat pensyarah yang mengajar tutorial kamu. Oh ya, kalau dekat saya dekat WhatsApp pun boleh. Okay. Untuk kalau ada masalah lah. Right? Nota dan soalan tutorial dan sebagainya tu nanti saya akan bagi di grup nanti ataupun kita akan bincang detail dekat soalan tutorial. I think that's all for today. Sekali lagi terima kasih. Untuk kelas ini sebenarnya saya lebih kepada nak test talian. Saya rasa pelajar pun saya rasa okey, tak ada masalah. Okay, talian okay. So next time mungkin kita lebih agak lebih proper lagi ya, lebih jelas lagi. So untuk lecture hari ini itu saja ya. Nanti apa masalah boleh rujuk dekat WhatsApp nanti lah, boleh hantar dekat WhatsApp. So thank you. Assalamualaikum dan salam sejahtera.